Alright, we're still here in section 4, looking with lines and triangles, looking at coordinate geometry. It says, given the triangle below, graph the midsegment MN, which would be parallel to XZ. So parallel to this line here, and it's a midsegment. It says, verify that this segment meets the criteria of a midsegment, which is that it is parallel and has the proper length. And midsegments are always half the length of the parallel segment. So the midsegment here is going to be somewhere in between, something like that. But we want to get an exact point for, an exact coordinates for where this starts and ends. To do that, let's go ahead and find the midpoint of this side here, because that midpoint is going to be where we draw our midsegment from. We have a 3 and we have a 5. The middle of 3 and 5 is going to be 4. And if you like to use the midpoint formula, 3 plus 5 over 2 is going to be 8 over 2, which is 4. And then the y-coordinate, we have a 9 and a 5. Halfway between 9 and 5 is 7, or 9 plus 5 over 2 is 14 over 2, which is 7. So regardless of which way you do it, it's 4, 7 here. And if we graph that, it's going to be right here. The reason you graph it is because it makes a very convincing visual case for you doing it right. That dot looks like it's exactly halfway across that segment. Now, same thing down below. We have halfway between 1 and 5 is going to be 1 plus 5 is 6, divided by 2 is 3. We could have figured that out. Same thing here, 1 and 5 again. Middle is 3, so our midpoint is 3, 3. Once again, that does in fact look like the midpoint of that line segment. We connect our 2 points, our 2 midpoints, and that forms a mid-segment. Now what we need to do is we need to verify that that mid-segment is half the length of the regular segment. After that, we're going to have to verify that it is parallel, and one way to do that is to verify that it has the exact same slope. So let's start out with the length. To do that, we use the distance formula. So we take our distance between our 2 midpoints, and this is going to give us our shorter segment. So distance between 3, 3 and 4, 7. We always do the difference between our x values. 4 and 3 are 1 apart, and we square that, and we add that on to the distance between our y values. 3 and 7 are 4 apart. Square that, and we add those terms together under a root. That leaves us with the square root of 1 plus 16, which is the square root of 17. And if you are looking for an approximate answer here, you could plug that into your calculator. In this case, that will be helpful. And that's approximately 4.12. Let's do the major, the full length segment behind it, XZ. And we are trying to find the distance between 1 and 3. They're going to be 2 apart, so our x's are 2 apart. Our y's, 1 to 9, are 8 apart. We go ahead and carry out the squaring here. 2 squared is 4, 8 squared is 64. Leaves us with square root of 68. And again, if you're looking for a decimal approximation, you can pop that in your calculator. You're going to get approximately 8.25. You'll notice here that these two numbers, if you account for a little bit of rounding error, the lower one is double the upper one. And that's what was supposed to happen. We were expecting that XZ here was going to be twice the length of that midsegment MN. And so we did in fact verify that the length is appropriate for a midsegment. Now we need to verify that the lines are parallel. So I'm going to clean up my picture a little bit here, get rid of some of these extra marks, and when I go ahead and do my slope, I'm going to start with the slope of XZ. Slope formula is always just rise over run. rise over run. I'm going to call this the slope of xz, and I use m as my symbol for slope the same way you would in the y equals mx plus b formula. So slope of xz, I need to find my rise over run, my difference between my y's over the difference between my x's. So the difference between my y's is going to be a 9 minus a 1. Then I need to find the difference between my x's. I have a 3 and a 1. Notice how I did top point minus bottom point for the x's, or for the y's and for the x's. It's important that you do the same order for both for the slope. Otherwise, you're likely going to get the negative sign wrong. Simplify this out, it comes out to 8 over 2, which is 4. Quick common sense check. This line segment is in fact going up, and it's going up fairly steeply, so it should be positive and it should be a big number. Positive 4 makes sense for those criteria. Now let's go ahead and do the slope of the midsegment. So the slope of mn, distance between the y's, we're going to take 7 minus 3, the rise, and then difference on the run, 4 minus 3. Come out to 4 over 1, which is 4. Again, visually, it's a steep upward slope, so a slope of 4 makes sense. And we did verify that 4 and 4 are the same, which means that the slopes are parallel. Same idea applies down to this problem here. We're given a triangle with some coordinates. First thing that we're going to need to do is graph this triangle. So if I were graphing it, I see no negatives in here. I'm going to go ahead and make my coordinate axes go along the edge of my graph. So this is going to be 0, 0. Point 26, go over 2, up 6. I have the point 8, 2. So I need to go forward 8 and up 2. I should label my points here. And then my final point is 11, 13. So 3 more over, and then 8, 9, 10. 13 is going to be up here. So I have all 3 of my points, and I'm going to connect my triangle together. Important thing to remember when you're sketching these is that they're probably not going to come out to be perfect sketches. You want to make them reasonably accurate because that way it will be more helpful to you, but you're going to trust in your coordinate math, either the slope that you calculate or the midpoints you calculate, things like that, over your picture, because that will be more reliable. The picture serves as an excellent check though. First thing is find the midpoint of AB, and they call that midpoint M. So AB, we need to label this as A, this point is B, and this point is C. So if we're finding the midpoint here, halfway between 2 and 8, add 2 plus 8 is 10, divided by 2 is 5, so we need to go over 5. It's going to be up to here. Halfway between 2 and 6, add 2 and 6, you get 8, divided by 2 is 4. So 4 is up here, and that point, midpoint M, is going to be right there, and that visually does look like the midpoint. So we found that. Verify that CM is perpendicular to AB. Now CM is going to be this segment that goes from the midpoint over here to point C over here, and they're saying that it is perpendicular. So we are assuming that it's perpendicular here, and we're not sure about that. So let's go ahead and calculate that out. We need the slope of this line, CM. We also need the slope of this line, and they need to be the opposite reciprocal of each other, which means that you take the fraction, you flip it, and make it negative, and that's how you should be able to convert between two perpendicular lines like these two. So let's go ahead and find the slope of AB. Slope of AB, going to be the rise over the run. So I take 6 minus 2, take my first point minus my second point, and then I take 2 minus 8. First point minus second point, and this I have the y's on top, the x's on bottom. I have 4 over negative 6. Reduce that to negative 2/3. Notice how I move the negative up to the top. It helps clean up the problem a little bit, and that's something that's totally legal to do. Now, common sense check, negative 2/3 is a gradual downward slope, and this is a gradual downward slope, so that's right. Now, I need to run my slope for CM. Slope for CM, my rise, 19 over, and I forgot to label this point earlier, my coordinate for that midpoint was 5, 4. So I take my 13 minus 4, my y's first, over my x's, 11 minus 5. And when I get that, I get a 9 over 6, reduces to a 3 over 2. Common sense check, it's a positive slope, reasonably steep, so 3 halves makes sense. These two numbers here, if you were to flip the fraction and change the sign from positive to negative or negative to positive, you could convert between the two. So in fact, it is perpendicular. Last step is to verify that AC is equal to BC. To do that, we do distance formula. So distance for AC, square root distance between the x's. So between 2 and 11, we have a distance of 9. Square that. Between 6 and 13, we have a distance of 7. Square that. We clean this up inside. Square root of 81 plus 49. Square root of 130. We don't need to plug this into our calculator to simplify it, since we're looking to see that we get an exactly the same answer. We're not looking for half or anything. So we're trying to verify that it's equal to BC. So let's find the distance of BC. Distance between 8 and 11 is going to be 3. Square that distance. Distance between 2 and 13 is going to be 11. So clean that up. We get 9 plus 121, which is conveniently square root of 130. So these two are the same. We verified that the distance between AC is equal to the distance between B and C. And that is the end of section 4.